I'm in an Apple facility. That is an iPhone. And this is the Fully Charged Show.
We know you love the Fully Charged Show.
So why not come along to our global live shows in 2023 and 2024?
Our next shows in the UK, specifically Farnborough and Harrogate.
So get your tickets before they sell out.
The way electronic waste is recycled today is typically through shredding operations.
Yeah.
And the reason why those are so useful is because they're universal, they can take anything in.
Yeah.
And we knew that for our robotic approach to be competitive, it needed to be able to do many different models of iPhone in one system.
Right.
And that was one of the primary goals for Daisy. And now we have 2 Daisies, one here and one in the US. And between the two, we can do 2.4 million iPhone models per year, 23 different models of iPhone in the one system with no changes in tooling, and that allows us to develop recycling technologies that help us move towards our corporate environmental goals that Apple has of one day making all of our products out of only recycled and renewable materials and being carbon neutral across our entire value chain by 2030.
So it's very easy to recycle electronics. You just put it in a massive crusher, it tears it to bits, and you end up with that, which is not terribly useful. Everything's like mashed up together. So this is a completely different approach. This is using Daisy. This is Daisy's arm. And Daisy removes the individual components. So there's 4 steps going on behind me. The first step removes the screen. The second step removes the battery. The third step punches out all the screws that hold everything together. And the 4th step removes the modules, all the little bits of electronics in the phone. And that means that everything is broken down to its component parts, which is what these huge bins are behind me. This is tons of really valuable material that can be used again.
So this is where the phones enter.
A bin full of phones?
Yeah,
wow.
Just a hopper of phones.
Wow.
And we can actually load any of the 23 models that Daisy is
capable of doing.
Because
they're all different sizes.
They're all different sizes, and this allows us to just take in the devices as they come and throw them in as a mixed batch. So this first robot is picking them up, and where you see that white square, it's actually starting to identify the model.
Right.
So it's measuring the size of the device and the orientation, and it starts to understand if it's an iPhone 6 family or if it's a plus size device, and it uses that information to start understanding how to process.
Yeah.
From here, that robot's going to place it into these nests.
Yeah.
And this is where the work really starts. So this robot is going to pick up these devices out of the nest. It's all going to happen quickly, but you'll see it'll pick one up. It's going to take another image, and that's to check the orientation. Here, it's going to separate the display from the enclosure, and then at the back there, it's going to pry them apart.
Peels it off. Wow.
And then once it's peeled off, it'll put it over there. And you'll see sometimes, like that phone there, once in a while, she makes mistakes. Sometimes it doesn't go as planned, and that's one of the hardest things with the engineering of these systems.
Right.
Automation is really good at doing the same thing over and over and over. But with recycling, you get every bit of variation possible, right? Because each of these phones has had its own unique life.
Yes.
So a lot of what we had to do is figure out how to make sure that when something does go wrong with the system, it can continue working with minimal disruption and it doesn't break anything.
Yeah.
The great thing with the Daisy program is that it has allowed us to really learn where existing technologies are already robust enough and where we might have to invest more effort and time, either ourselves directly, our own engineers, or working with the best recyclers in the world. For some outputs like the cameras and the main logic boards and flexes, 1 metric ton of the outputs from Daisy has the same amount of copper and gold than over 2,000 metric tons of mined rock. So it's a huge impact and reduction in the amount of mining that's required when we are recycling these devices.
How fast is Daisy then in terms of recycling? Because it started out, the first one was like 11 minutes to do
12 minutes,
12 minutes.
So Daisy can do up to 200 units per hour. So that shakes out to roughly 1 every 18 seconds.
Right. I bet you've got an old phone, an old smartphone sitting in a drawer on a shelf somewhere gathering dust. And you've had it there for years, you don't use it anymore, it doesn't work. Well, what about this? If you were to recycle that, that could really change the way that we extract and use materials. It could reduce the amount of stuff we have to dig up. If you imagine all the smartphones in the world, let's just stick with Apple for a minute. 2.24 billion iPhones have been manufactured and sold by Apple. It's a phenomenal number. And so there's a lot of material in that. And this really relates to everything we're talking about with electric vehicles and the new technology. What do we do with batteries at the end of life? Do we just throw them away? No, we don't. We come to facilities like this and we break them down into their component parts and recycle them. So if you've got an old phone, take it in. You can trade them in sometimes. Don't just leave it in a drawer. It's got valuable materials in, and that's what we're going to discover here today, is when you combine millions and millions of these small electronic devices, what's in them turns into tons and tons of really useful and valuable material.
Now that we have a phone where the display has been removed, we're now focused on removing the battery.
Right.
And what you can see here is we have 3 battery removal stations.
Right.
And you see that fog, essentially, that's created. That's because we're using -80 Celsius air.
Right. Wow.
So it's really, really cold air. There's no gas, it's just air.
Right. But that breaks the glue then that it's stuck
Exactly.
with.
Yeah. So we found the temperature where it's colder than the design of the kind of the durability design of the product. So you're not going to go skiing and your battery's going to fall out.
If your phone gets to -80, you're probably in a whole other world of pain.
Exactly, yeah. And we chill the battery for somewhere between 20 and 45 seconds, depending on the model. And then we actuate it, and that causes the battery to fall out.
So one of the kind of areas that we're really interested in on Fully Charged Show is battery recycling. It's becoming a really big topic, and how much. But then presumably the batteries in phones are so tiny in comparison with a car. But when you're recycling millions of phones, that's a lot of batteries. Can they be recycled? Can you reuse the materials that are in the batteries?
Yeah, we actually just set the goal, just made the commitment to source 100% of the cobalt in Apple-designed batteries as recycled content by 2025. So it's something that we're looking at really closely. And Daisy has actually contributed over 11,000 kilograms of cobalt back into the recycling supply chain. So it's something that is really important. Of course, batteries, most consumers understand that it's something that is important to recycle. And with our initiatives, what we want to make sure of is that they know that it's easy to bring these old devices back to Apple, and we can make sure that they get the best recycling process possible and maximize the recovery of these resources. Now that the batteries are removed, we have the rest of the phone, and we now have a bunch of different modules that have different materials in them. And what we found was that the best way to remove the screws that are holding in those modules is to actually just punch them out. Yeah. So Liam 1 and Liam 2 before Daisy, we used to actually unscrew everything. Right. We kind of reversed the assembly process. Yeah. But it was too slow. It wasn't flexible enough. Yeah. And we found that by doing it this way, we can of course do it a lot more quickly. The other advantage that we found is that this actually allows us to remove some of the other contaminants. Right. So that we can get a cleaner aluminum output out of it. Right. So we can use it to selectively remove certain metals that we know are going to cause a reduced quality in aluminum recycling. Right. But you can see here, the system knows which phone it's processing, where the different screws are, and it just quickly goes around and knocks them all out so that the modules are then freed up and ready to be removed. We already have really robust programs for recycling any of our devices, so we're working with the best recyclers around the world so that whether it's an iPhone or a MacBook or an iPad, when these devices come back to Apple, we're going to make sure it goes to the best-in-class recycler globally. But we're also investing in new technologies and doing R&D to figure out how can we bring these new recycling approaches to any type of electronic. We have a lot of research in the machine learning and robotics space with academic institutions where we're looking to see how we can bring new machine learning classifiers to identify any type of device so you know how to recycle it. Right. And similar to our approach with Daisy where we're offering to free issue the licenses to the IP, with our sponsored R&D with academic institutions, we're actually making as much of it as possible open source so that others can copy that as well. So it's an area that we continue to invest in, and we're spending a lot of effort to figure out how we can push recycling technology to catch up to the innovations in consumer electronics. So then from here, once it's done punching out all the screws, we go to our last station, and at the back you can see a spinning tool going around. What that's doing is just knocking the different modules out. So now all the screws have been removed. There's a little bit of sometimes just mechanical interlocking that keeps them in there.
Right.
And that allows them to fall out onto this conveyor, and they come out to the front of the system where we now have kind of discrete modules that can be sent to the right specialty downstream recycler.
Wow.
And that allows us to make sure that every module that comes out of this can be sent to the best recycler to get the highest recovery rates for the materials that are contained within. And you'll see things like the audio modules, which have rare earth magnets. We want to send this to someone who can actually recover those magnets and those rare earth elements, so that we can get that material back into the global supply chain.
Right. But I mean, it's going to be possible then in the next, say, I don't know what, 10, 15 years, that you'll be able to go into an Apple store, buy a phone that is close to 100% of the materials in it have been a phone before.
Right.
Which is extraordinary.
And we're already making a lot of great progress towards that goal. So actually last year, almost 20% of the material shipped in our devices was from recycled content.
Wow. Okay.
So already a huge progress towards that long-term goal of making our devices out of only recycled and renewable material. And we're not gonna stop until we get to 100%. So hopefully soon we'll be in that position.
Yeah. So it's going to take a while before there are enough daisies to recycle all the phones, the same amount of phones that are being sold every year. But that is the intention that Apple have, to recycle everything that they make at some stage in its life. But what we've got to do as users of this stuff is make it last as long as we can, to look after it as well as we can. And then at the proper end of life, don't just leave it in a drawer up on a shelf gathering dust. Take it to Daisy. She's hungry. She needs more iPhones. I can't help doing this. I'm going to do it. She wants to mash them up, strip them down, use the materials again. It's really, really important. But it's been an amazing day here in this facility to see what they're doing here, to see the detail and how much of this material. Look at that. That's tens of thousands of phones broken down into its component parts, going off to be recycled so that material can be used again. Really, really important. And it applies to everything we make.